myself Ishwara from India. So, first of all, thanks for giving this opportunity. Mostly for Hey Hamara AI team. Thanks for once again. So let's start our presentation. See, my application name is Sentinel, which is integrated with the LLM in local, which is locally run LLM, and this application can able to detect your activity on file systems based on the rules, all those things. So and now I give you a brief introduction about my project, all those things, and their features and architectures and whatever the my scope, all those things. In upcoming slide we can start actual explanation of this project. Once again, welcome to the this project. So the main aim of this project is actually this project can accept human readable uh, rules, means natural languages prompts, and able to convert into rule patterns or rules by using LLM. Okay, and this project can able to monitor your file system and trigger notification against whenever the new events are happening in the file system. Then automatically logs and alerts are created through AI, as well as this system can able to learn new rules which is given by the user in the general language, means in English, then automatically converted into a rule by using LLM, which is locally present running in my local system only. Okay, my main motto is whatever the rules are existing in our application that can be used to identify or track the system activity or a file system activity by using LLM, and we can introduce new rules also that can able to that system can able to learn new patterns, all those things. So the here I give you a brief introduction once again about this. Actually, this is one of the AI-based file monitoring system with by using LLM. So this application can able to continuously monitor your file system, which is in real time, and learns monitoring rules from plain English using AI. And also the rules and observations are logs, all those things persisted in JSON files format present. Okay, and it give you alerts and logs whenever you defined conditions are met. Then the AI comes into picture. Then the AI agent or AI can operate your application like triggering logs, identify the patterns, all those things. And the most thing is it is fully run in a local system only, and privacy control, all those things, and free of cost. And other one is it is a it is basically this rule system, this application runs on a daemon thread which is run in your project background. Once your project is started, then daemon is created, then running in your background. Okay, that can be help to running your application continuously, as well as communicating with your AI system, LLM, all those things. I can explain how it will happen in next slides. Okay, so these are the tech stack I used for implementing this project. For Node package manager, if I used for runtime, I used Node.js. It always runs on a daemon execution. And for language, I use TypeScript, end-to-end, type safe, and very clear. And for file system monitoring, all those things, I used Choke which is one of the npm library, and it can support cross-platform file system watcher. It is open sourcely available on the online. And the other one is I used Olama, which is locally installed, means it is run in our local system only, and it can able to convert your natural language into rules, okay, and executable patterns, and it is fully local interface, no cloud dependency, zero tokens, and free of cost. And for front end, I use a Next.js and Tailwind CSS, and I use Shadcn also for a best UI uh, interfaces. So these are the tech stack I used in this project. And the next one is, now we are going with architecture. This is the main important and backbone of the our challenge. Based on this architecture, we can solve that. We developed that application, as well as we identified that data flow, triggering alerts, rule creation, training our rule engine, learning new things, all those things. So the overview of this architect is, actually this Sentinel follows a local first daemon driven architecture designed for continuous observations on the file system in real time. Basically, a Node.js TypeScript daemon runs continuously in the background when your application up. Main it is bootstrap. Then, if any events are occurred in file system, any created, then your chalked captures file system events in real time. Then it triggers that observations to the AI engine. The AI engine interrupts your language's rules. Okay, it can able to convert your local means your English uh, language into natural language into rules. Okay, and the one more thing is I can save those logs, rules, and matches, all those things present in you in the form of JSON and a JSON format locally only. Okay, after that I created one of best UI for interacting with our application. It can capture live data events, all those things I can show you later. The main thing is, this is the very important architecture. It includes both front end and back end also. Okay, this is my high level architecture. Means here the Sentinel is a local always run on daemon that observe file system events, evaluates them against a learned rules, and persists outcomes locally in the form of JSON files. And after that I visualize that everything through the dashboard. Okay, whenever the user uh, entered into the dashboard, there is a lot of options like creating new rule, view rules, view alerts, view logs, all those things, and there is a lot of options. And once you if you want to create any new rule, you can enter your prompt in a natural language in English. The system means the LLM can automatically convert that language into rule based language using different patterns, and it can able to identify security patterns, all those things. Okay, this is my high level architecture in the point of both front end and back end. uh, I will show you example demo also how the UI works, dashboard works, all those things. Okay, so this is the overflow. This is the flow diagram of AI rule learning process. How actually our LLM can learn new rule against existing rules. When the user enter a English language new rule in the form of general language, natural language, means in English. For example, if I enter alert if a env file changes, means any changes happening in the .env file, then automatically the local LLM interrupts the intent extract that conditions and suggest the patterns. Then the we got that structured format. Okay, now that English can be converted into a structured format by using local LLM. Okay, then the rule engine can identify that new rule which is created in our system and identify the conditions, guess, observe the patterns, all those things, then applied into our system. Okay, finally we save that information in rules.json. Basically, this AI use it to interrupt intent, not to executable logic. Okay, execution remains deterministics and debuggable. Okay, I give you a brief introduction in the next slide. Okay, this is the flow how actually our feature work in our application. The first is whenever you change any file in our targeted file system, then automatically that event is captured by the your chalk deer node dependency. Okay, like an event, it is triggered an event in the form of payload, and this event payload is add to your event queue in memory only. Okay, then evaluated by the rule engine, means it can identify if that event is matches with our existing rules or not, detecting that behavior, all those things. Once that pattern is identified, then it will send that information to notification system. It will triggers you an alert or a prints a log on console. Okay, and that save that information in present JSON file formats only. Then this information read by the our dashboard, which is showing live updates, historical updates on the dashboards. I will show you that also in the future, in upcoming slides, all those things once this presentation is completed. Then what are the features I introduce through this application? Those are, the first one is understanding of natural languages, means it, this application can understand your natural language. Okay, and other one is converted them into a dedicated rules, means it can be a dedicated formatted rules. It have a different parameters, all those things. This can be handled by our LLM. Okay, and other one is it can able to monitor your real-time data, real-time events against file monitoring system. Okay, I will show you that also in live. And other one is the main one. It have, it can save all your data, rules, logs, alerts, matched rules, all those things in a JSON file format, present local only, and it can support local first design, not a cloud. It is run in my system only. Okay, and after that, how it works? Actually, how it works means first user define the role in English language. The LLM can convert that English language means prompt into a pattern that can be done by uh, our LLM, and learn it at the same time. It can learn that new rule and identify that pattern. Okay, that's then saved into the our JSON file. Then, if any file system events are detected by the Chokidar, then automatically the our LLM can apply the rules on that detected event. And if any rule is matched, then automatically our notification system triggers a new notification, means like your rule is matched, all those things. It can save your, and it can also save all logs, matched rules, all those things in JSON file. And then automatically your dashboards read that all those logs, real-time information, and showing in visually on the dashboard. Okay, yeah. Now, how I can use AI in this application. This is very important. I downloaded Olama from online and integrated in our my application. Basically, this Olama is for it can learn new rule as well as it can apply rules against events which is happened created on file systems. Means it can able to read your, it can able to convert your natural languages into rules, and it can be applied on the behavior application behavior, as well as it can able to execute the rule and patterns also. Okay, this is fully automated and the local first design. Okay, this is entire behavior is only that is what is that word controlled by our LLM only. Okay, then what is the differences? This is a different trade-off visualization I give you from my side. What I observed all those things. Sentinel is my application. The cloud AI monitors is which are already available in the markets. Okay, this is a small comparison from my side. My application first, local first LLM only, means no need to pay anything, zero cost. Okay, you can inspect, means you can able to inspect any time of any time, different modes, debugging all those things, and you can update your logics also, no problem. Why? Because it's in your local system. The other one is cloud monitoring. Means it is when comparing with my local system, you need to pay something, means it's expensive. Okay, it is centralized, and one of the most advanced feature is it can support multiple devices. Means anyone can connect and able to use these features. Okay, this is one of the advantage. Yeah. uh, I want present this application runs on my system only. So every system I identified a different enhancements in future. I want to apply these features uh, in future as enhancements in our application. The first one is I want to uh, s- integrated this application into cloud. Means then if you this application available in a cloud, anyone can connect remotely. That is one of the best option. And I want to make it as a plugin architecture. Means any new feature, any new updates are available, it can automatically pluggable manner. That is only uh, decided by your architecture, how your plan your architecture, then only it can possible. The another one is I want to store all your real-time data, all those things in the database instead of JSON files. This is my future enhancements. So yeah, this is my application, entire application. So thank you. Now after this I will show you a live demo how my application works, how dashboards are captures live data, how rules applied, how new rules are created, all those things. Yeah, now I will show you our project.